Okay, I'd like to do a homework problem that tends to cause students a lot of trouble. So this is a rational function that we're dealing with here, and it tells us that it's one-to-one because we haven't learned how to graph a rational function yet. So they need to tell us that it's one-to-one, and they want us to find an equation for f inverse or the inverse function. So remember the steps. The very first thing that we need to do is rewrite this function as an equation. In other words, y is equal to 4x plus 7 over x minus 5. Now the idea about an inverse function, no matter how you look at it, is the x's and y's are flipped. So that means the y turns into an x value and the x turns into a y value. And notice we have a y value in the numerator and the denominator. And now my goal is to solve for y. Now, you know, to solve for y, if there's a variable that you're trying to solve for in the denominator, you're going to have to multiply both sides by that denominator. That's going to be the very first step for sure, because we need that y minus 5 out of the denominator. Okay, so now it's over here on the left side with the x. Now remember again, we're trying to solve for y. There's a y right here, but the problem is there's also a y right here. So we're going to need to get all the y terms on the same side. So in this case, I'm going to have to distribute that x inside. Okay, so this is going to give me xy minus 5x on the left equals 4y plus 7 on the right. Now again, notice that I have a y on the left side of the equation and a y value on the right. If I'm solving for y, both of those terms need to be on both sides of, on one side of the equation. So what am I going to do? I'm going to subtract, we'll do this in a different color to make it clear, this 4y to this side. So I'm going to minus 4y and I'm going to minus 4y. Also, this minus 5x, I don't need it on this side, so I'm going to move it to this side. So I'm going to add 5x. I'm just adding underneath. I'm not putting it under like terms or anything like that. My screen moved rather than my line. Hold on just a second. Okay, now that I have my screen back, I'm going to draw that line like I want. There it is. Okay, so what's going on? This minus 5x and this plus 5x cancel. So on the left side, I have xy minus 4y. On the other side, this 4y and this minus 4y cancel. So I have 7 plus 5x. So again, my y terms are on one side. My non-y terms are on the other. I probably made this in green right here more confusing than it needs to be. If you want a term on the other side, move it over there and change the sign. So notice this 4y turned into a minus 4y. If you want this minus 5x on another side, move it to the other side and change it to a plus 5x. Now what? I got to solve for y. I can't because I've got two different y values here, or two different terms with y in it. I'm going to factor. Okay? That's going to give me x minus 4 on the left and 7 plus 5x on the right. Now finally, my last step to solve for y is I want to move this x minus 4. It's being multiplied by y, so to undo that, I need to divide. Remember, to do something, you want to undo it. Just like I wanted to get rid of this 4y, I subtracted it because it's just a positive over here. Well, to get rid of multiplication, you divide. So those cancel. So now I have y is equal to 7 plus 5x divided by x minus 4. That's my inverse, so I use the proper notation, f inverse of x, and then what you're asked to actually type in is the 7 plus 5x over x minus 4. But it also wants to know what values can you not use in this function. Well, y'all, the denominator, if I plug in a 4, the denominator is going to be equal to 0. So again, what makes that denominator equal to 0? A 4. So x is not allowed to be 4. How did I find that? Really, I just said x minus 4 equal to 0. I add 4 to both sides to get x is equal to 4. That's the bad guy. You want to take that out of the domain. It typically doesn't ask for an interval notation, but if it did, it'd be minus infinity to 4 with a parentheses using 4 to infinity. Now, the next step, it wants us to verify that your equation is correct by showing that f of f inverse of x equals x and f inverse of f of x equals to x. Now, in your homework, they make that actually very easy. They just put, let me change colors for you, f right here, and then they put a box right here. And you're just supposed to plug in f inverse of x, which is 7 plus 5x over x minus 4. And then the next line, they want you to simplify it, and it should equal to x. What they're really trying to do is to get you to do that work, though, and I want to show you that work. So on the next page, that's what we're going to do, is really do the work to show you that f of f inverse of x equals x and vice versa. All right, so I've erased. Let's continue where we left off. So the boxes you type in for f, and this is f inverse. But again, let's really do the work, and it's a decent amount of work, so just hang tight. So f of 7 plus 5x over x minus 4 is actually going to be, my f function is right here, so it's going to be 4 times 7 plus 5x over x minus 4 plus 7 divided by my x again is 7 plus 5x over x minus 4 minus 5. Now that is supposed to simplify to give me x. And we've got to figure out if it does. Well, how am I going to do this? Well, the first thing you could do is distribute this 4 in the numerator here, and then we can find a common denominator so we can add these fractions together. Same thing down here. Again, it's a sufficient amount of work. So you have 28 plus 20x divided by x minus 4 plus 7. Let's go scoot on down to the denominator and work on that too. Well, I'm just going to rewrite it this time. 7 plus 5x over x minus 4 minus 5. Now again, I've got this 7 is over 1, so I need a common denominator, which is x minus 4. So I'm going to multiply this numerator and denominator by x minus 4. I'm going to do the same thing for this 5, because it is really 5 over 1, right? Now let's scoot to the right and see if we can get all this simplified. Hard to believe that this is all supposed to turn into x, but it's supposed to, so let's keep going. So I have 28 plus 20x, okay, plus 7x, I'm distributing here, minus 28, and that's all over the common x minus 4. I'm going to do the same thing in the numerator. I have 7 plus 5x. I've got to distribute this negative 5 inside here. So negative 5x plus 20. This negative 5 times this negative 4 is plus 20 divided by x minus 4. Now if I keep going, on top here, this 28 and this minus 28 cancel. 20x plus 7x is 27x over x minus 4. In the denominator, big denominator right here, 5x cancels with minus 5x. 7 plus 20 is 27 over x minus 4. Now you know what you should know, what you do when you have a fraction divided by fraction. You flip the denominator and multiply. So you have 27x over x minus 4 times x minus 4 over 27. This x minus 4 cancels with that x minus 4, and this 27 cancels with that 27, and that really does give us x. Now, I bet you didn't do that when you tried the homework problem. Everybody's going straight from here to here and just assuming that it's x. But this is the true check to show that it's x. And listen, that's only half the check. You're supposed to check it the other way as well. So they write f inverse, and they put a box right here, and you're supposed to plug in your original function, which is 4x plus 7 over x minus 5, and the work is very similar. So similar that I'm not going to do it for you unless you send me an email and ask me to, just because of a time issue. I wanted you to see the how-to, and really it's the first page how-to that I'm most concerned about for this problem. about inverse functions, and it's a rational function. Hope this helps you out.